want to solve triangle ABC, and what we know about this triangle is that angle A is 40 degrees, side A is 12, side B is 14. So the information given to us is a side, and an angle. So in the side-side angle case, we're going to use law of sines, and we're going to have to be careful because this is a triangle that could have one solution, no solutions, or it might not have any solutions at all. The triangle might not exist. So to get started, we're going to say the sine of 40 degrees over 12 equals the sine of angle B over 14. So 14 times the sine of 40 degrees will equal 12 times the sine of angle B. And so the sine of angle B is going to equal 14 times the sine of 40 degrees divided by 12. So angle B is going to be the inverse sine of 14 times the sine of 40 divided by 12. So second sine of 14 times the sine of 40 divided by 12 gives us that angle B is 48.583 degrees. Now, because when we use an inverse sine, sine is positive in both the first quadrant and the second quadrant, then we might also have another value for angle B. So angle B could also be 180 minus this value, which would give us 131.417. So to determine whether or not both of these could be the values in our problem, if we were to let angle B equal 48.583 degrees, then that would make angle C be equal to 180 minus 48.583 plus 40, which was the other angle in our triangle. And that would make angle C equal 91.417. Or, if angle B is equal to 131.417, would there be enough degrees left in the triangle for angle C? So if we take 180 and we subtract 131.417 plus the 40 degrees we already know we have in our triangle, we come up with angle C is 8.583. So there are indeed two triangles that work in this problem, because we had two different choices for angle B, and then using that angle B along with the 40 degrees we already knew we had in the problem, we came up with degree measures for angle C. So from this point forward, we're going to need to find side C using the two different values for angle C that we had to complete solving this triangle. So let's find side C for the first triangle. The sine of 40 over 12 will equal the sine of 91.417 divided by side C. And so if we multiply, we'll have C times the sine of 40 equals 12 times the sine of 91.417. So C is equal to 12 times the sine of 91.417 divided by the sine of 40, which gives us that side C is 18.663. And in this particular problem, they didn't give us units, so it's 18.663 units. For our other triangle, we would have the sine of 40 divided by 12 is equal to the sine of 8.583 divided by side C. And so if we do the same thing that we just did, cross multiply and then divide, we would have 12 times the sine of 8.583 divided by the sine of 40, and we'll end up with side C is 2.786. So we ended up with two different triangles. In our first triangle, angle B is equal to 48.583, angle C is equal to 91.417, and side C is equal to 18.663. In our second triangle, angle B is equal to 131.417, angle C is equal to 8.583, and side C is equal to 2.786.